Hey guys, it's Mr. Schmidt here, and in this video, we're going to look at cost-benefit analysis. So, when economists think about decision making, we like to think about it in terms of costs and benefits. And when we say cost-benefit analysis, what we're talking about is comparing total benefits and total cost of some activity to reach an optimal outcome. In other words, to maximize total benefits, minimize total cost, making sure that we're getting the most out of whatever activity we're deciding to do, right? And this has a lot of practical applications, right? So, for example, maybe a school board is deciding that they want to build a new playground, but they're looking at, okay, how much benefit would that playground in terms of a dollar amount give to our community versus how much would it cost to make it? That would be an example of cost-benefit analysis. And so an optimal outcome is one in which net benefits, defined as the difference between total benefits and total costs, is maximized. So in other words, when I take my total benefits and I subtract out the total costs of that activity, that the result should be the biggest number possible. Then I will know I will reach the optimal outcome. And another practical application of this is deciding how much education you should get, right? Because every amount of education, every degree, bachelor's, master's, doctorate, etc., each of those degrees will increase your salary, right? You'll get a bigger and bigger salary, but it's also costing you more and more and more to get that education. And so do the total lifetime earnings of that degree justify the total costs of getting that degree? Okay, so let's look at an example here. And so we've got basically how many times we're doing an activity, how much it's costing us in terms of a dollar amount, and how much we value it in terms of a benefit. Okay, and so the question here is, what is the optimal number of times we should do this activity to reach, excuse me, a preferred outcome? And so basically what we do here is we notice, okay, here's total benefits, TB, here's total cost, TC. So I'm going to take column 2, subtract out this is really column 3, column 2, column 1. So take column 3, subtract column 2, whatever row has the biggest result is going to be the optimal number of times to do this activity. So what we could do here is we could add another column to this chart and then go ahead and calculate the net benefit. So 0 minus 0 is 0, 12 minus 2 is 10, 22 minus 6 is 16, 30 minus 12 is 18, 36 minus 20 is 16, 40 minus 30 is 10, then we've got 0 and negative 13. So what you notice here is the net benefit starts to increase and then eventually goes back down. It if we were to graph it, it would have this upside down parabola shape, which makes sense, right? Because at first when we start doing this activity more and more and more, we might get increasing amounts of enjoyment out of it, right? Like it's outpacing the cost because we've only been doing it a few times, right? Think about like eating your favorite candy. When you first start eating the candy, boy, that benefit really makes you forget how much money you paid for the candy. But at a certain point, you start getting full and you start getting tired of the candy, maybe even a little sick from the candy, and that total cost is starting to creep up on that benefit until you're actually losing value by consuming the 7th unit or consuming 7 units of this good. So the optimal number of times to do this activity according to our chart would be 3, because the net benefit is as high as it possibly can be. So that's all for this brief video on cost-benefit analysis. Until next time, have a great day.